In this module, we will be looking at how an A320 pilot and the aircraft computers interface to ensure safe and accurate flight with minimum workload for the crew. For clarity, most references will be made to manual flight inputs. However, the references apply equally to automatic flight unless stated otherwise. A side stick or an autopilot sends a message to the flight control computers demanding an aircraft maneuver. The flight control computers process the demand and send it to the control surfaces. The processing uses preset limitations and instructions called laws. The aircraft responds conventionally to the movement of control surfaces. Normal law is modified depending on the phase of flight. It operates in three modes. Ground mode operates on the ground when the aircraft is electrically and hydraulically powered. Controls are conventional. Flight mode operates in the air after a gradual transition from ground mode, just after liftoff. Flare mode modifies flight mode to introduce a conventional feel to the landing phase. Will be discussed later in this module. We will compare a conventional aircraft, an A310, with the fly-by-wire A320 in normal law flight mode. Control surface deflection is directly proportional to control yoke deflection. The same yoke input produces a higher rate of pitch and roll at high speed, lower rate of pitch and roll at low speed. Control surface deflection is not directly proportional to side stick deflection. A side stick deflection gives a rate demand to the flight control computers. The flight control computers set control surface deflection to meet the rate demand. For the same side stick input, the control surface deflections will be large at low speed, but small at high speed. A side stick input is a rate of roll demand in roll, load factor G demand in pitch. Yaw control is conventional. Remember, the A320 responds conventionally to the movement of control surfaces. However, unconventionally, the response information is fed back to the flight control computers. The computers process this feedback and adjust control surface deflection to ensure that the maneuver rate demand is executed accurately. This means that control surface deflections may be altered with no change in side stick position. In flight mode, if you wish to execute, for example, a left turn, you set the required attitude and then return the side stick to neutral. The neutral side stick position demands 0 rates of pitch and roll. The flight control computers will maintain the set attitude until you use the side stick to demand an attitude change. Throughout the maneuver, there are no pilot trim inputs. Turn coordination and Dutch roll damping are automatically provided in normal law. Pilot inputs on the rudder pedals are not required. Normal law provides a number of airborne pitch protections. They are maneuver protection, load factor, pitch attitude protection, High angle of attack protection. High speed protection. In lateral control, there is only one protection, which is for bank angle. Let's take a closer look at these protections. In a conventional aircraft, pilots must ensure that structural limitations are not exceeded. However, in the A320 family, maneuver protection, load factor, is available in normal and alternate law. Maneuver protection, load factor, prevents structural overstress by limiting control surface deflections through the flight control computers. Full side stick movement is always available. The structural limitations vary with configuration. In clean configuration, between plus 2.5 G to minus 1 G. Flaps extended between plus 2 G to 0 G. As with the maneuver protection, if the aircraft reaches the pitch attitude protection nose-up limits, then the flight control computers will override pilot demands and keep the aircraft within the safe flight limits. The pitch attitude protection limits are shown as small green dashes on the PFD. Note that the pitch-up values vary, depending on the aircraft configuration and speed, between 30 and 20 degrees up. In the nose-down case, the computers will limit the nose-down attitude at 15 degrees. The high angle of attack protection is designed to prevent the aircraft from stalling and to ensure optimum performance in extreme maneuvers such as wind shear or GPWS warning recovery. This protection takes priority over all others. This protection displays information against the PFD speed scale. As speed decreases, it reaches VLS, the lowest achievable speed with autothrust engaged. With autothrust inoperative or not engaged, the speed can reduce to the first level of angle of attack protection, V alpha protection, which is shown at the top of the amber-black band, the barber pole. The flight control computers will maintain the speed at V alpha protection. If the pilots override V alpha protection using the side stick, the speed can reduce to V alpha max. In normal law, the flight control computers will maintain V alpha max even if a pilot holds a side stick fully aft. Nose-up pitch trim is inhibited. In the protection range, the normal law demand is modified and side stick input is an angle of attack demand instead of a load factor demand. To summarize, when alpha protection is triggered, the following actions occur. 1. The stick commands AOA directly, but not to exceed VA max. 2. Auto trim stops. 3. The speed brakes auto-retract. 4. The autopilot trips off. 5. Bank angle is limited to 45 degrees. Provided the autothrust is serviceable, the speed is unlikely to reduce to V alpha max before the alpha floor protection is triggered. This is indicated by an A floor indication on the PFD FMA and also on the EWD engine warning display. If the pilot releases the side stick at V alpha max, the speed will return to and maintain V alpha protection. The protection we will look at now is the high speed protection. It is designed to prevent the aircraft from exceeding maximum speed. This protection limit is displayed on the PFD speed scale. VMO/MMO is shown at the bottom of the red-black barber pole. Green dashes indicate the speed at which the protection is activated, plus 6 knots. When the airspeed Mach increases above VMO/MMO, an overspeed ECAM warning is triggered. If the airspeed Mach increases to the protection speed, the autopilot will disengage and the flight control computers send a pitch-up command to the control surfaces to prevent further acceleration. The flight control computers will permit momentary exceedance of this speed for maneuvering if necessary, but will then return to the protection speed. When high-speed protection is triggered, the following actions occur. 1. The autopilot trips off. 2. The computers induce a pitch-up command. 3. Bank angle is limited to 45 degrees. 4. If the stick is neutralized, the wings will automatically roll level. If high-speed protection has been triggered, the pilot cannot override the automatic pitch up. Under normal law, bank angle protection limits the angle of bank to 67 degrees, shown by green dashes on the PFD. If the pilot holds full lateral side stick, angle of bank will increase and maintain 67 degrees. The flight director, FD, on the PFD will disappear if the angle of bank exceeds 45 degrees. If the side stick is released at any time when the bank angle exceeds 33 degrees, the aircraft will return to and maintain 33 degrees bank angle. The FD will be displayed again on the PFD when the angle of bank reduces to less than 45 degrees. Auto trim is inhibited above 33 degrees. If angle of attack protection is active, angle of bank is limited to 45 degrees. If high-speed protection is active, angle of bank is again limited to 45 degrees. However, if the side stick is released to neutral, the aircraft will return to wings level. A single failure cannot result in the loss of normal law. However, multiple failures of flight control, hydraulic, or electrical systems may result in a degradation from normal law. The level of degradation will depend on the severity of the failures. Degradation of the flight control laws is sometimes referred to as reconfiguration. We will look at these in order of increasing severity. Assuming the failure occurs while in flight, pitch control retains load factor demand the same as in normal law. Roll control reverts to direct. Surface deflection is now proportional to side stick deflection. Roll is more sensitive and aircraft reaction is proportional to airspeed. Yaw control. Turn coordination is lost and only limited yaw damping is available. Landing mode. Aircraft reverts to direct law in all axes if the autopilot is off when the gear is extended. Degradation to alternate law is indicated by the ECAM caution, Flight Control Alternate Law, Protection Lost. Pitch attitude protection is lost. The computers will no longer limit nose-up or nose-down pitch. On the PFD, the green dashes, which mark the protection limits in normal law, are replaced by amber crosses. Bank angle protection is lost. On the PFD, the green dashes are replaced by amber crosses. Load factor protection is still present. The G load limits remain the same. In alternate law, the high angle of attack protection, AOA, is replaced by stall warning. Low speed stability may or may not exist, depending on the failure. B alpha protection and B alpha max are replaced by a stall warning speed, VSW, indicated by a red and black barber pole. If low speed stability exists, a gentle progressive nose-down pitch input is introduced to lower the nose and prevent further speed loss as the speed approaches 5 to 10 knots above VSW. The pitch input can easily be overridden by pilot input on the side stick, and the airplane can be stalled. At VSW, an aural stall, aural warning is triggered, along with the stall warning cricket. The aircraft will stall if the warning is ignored. Alpha floor protection is inoperative in alternate law. In alternate law, high-speed protection is lost. It may or may not be replaced by high-speed stability. The green dashes indicating normal law disappear. Above VMO or MMO, a nose-up input is introduced to raise the nose and prevent further speed increase. This pitch tendency can be overridden by the pilots. As in normal law, if VMO-MMO is exceeded, the overspeed warning is triggered. Depending on the failure, stabilities may or may not exist. There is no way of knowing without reference to the flight manual or by approaching the minimum or maximum speed. Airbus has restricted speed to 320 knots to prevent an incursion into the high-speed regime. As for low speed, the pilots must exercise the same care and attention they would when operating a conventional airplane. Should inadvertent incursion occur, both stall and overspeed warnings are still operative. Even if stabilities do not exist, the airplane is still protected by load factor. Load factor limits are the same as for normal law. Clean, plus 2.5, minus 1.0. Flaps extended, plus 2.0, minus 0.0. Direct law is the lowest level of computer flight control. Pilot inputs are now sent directly to the control surfaces. Because of the large number of failures required to degrade to direct law, it is unlikely to occur during normal flight. It is most likely to be encountered when the landing gear is lowered after an in-flight degradation to alternate law. Direct law, as the name implies, gives a direct relationship between side stick movement and the deflections of all surfaces. In effect, the A320 behaves like a conventional aircraft, and control sensitivity will depend on airspeed. In direct law, there are no protections available, although stall and overspeed warnings will sound at the appropriate speeds. If the airplane has degraded to alternate law while in flight, it will further degrade to direct law when the landing gear is extended. You will get an ECAM warning. Since auto trim is no longer available, you will also get an amber Use Man Pitch Trim message on the PFD. The pilot must now trim the airplane manually with the pitch trim wheel. Automatic turn coordination and yaw damping are also lost. Any necessary yaw control must be made directly through the rudder pedals. In the worst-case scenario, such as complete loss of power to all flight control computers, the aircraft will revert to mechanical backup mode. In this mode, pitch control is accomplished by manually trimming the stabilizer by using the pitch trim wheel. Some pitch control can also be gained by use of thrust. In mechanical law, man pitch trim only appears in red on the PFD. Lateral control is achieved primarily by using the rudder pedals. Some lateral control is also available through thrust. In most cases, resetting the flight control computers will allow recovery from mechanical backup to either alternate or direct law, depending on the type of failure. In normal law, all protections are available. In alternate law, the pitch attitude protection, bank angle protection, AOA protection, and overspeed protection are lost. Load factor protection remains. In alternate law, without stabilities, the high speed and the low speed stabilities are also lost. Again, load factor protection remains. In direct law, all protections are lost. Control is achieved by a direct stick-to-surface input, and the aircraft flies like a conventional aircraft. In mechanical backup, no protection exists. The pitch control is performed via the pitch trim wheel and the lateral control through the rudder pedals. Thrust may be used as desired. You have seen all the different laws and protections. What happens, though, when external forces cause the aircraft to leave the protected envelope? Severe turbulence or a thunderstorm. If the limits of normal laws are exceeded, abnormal attitude law becomes active. This is a safety feature to ensure that the flight control computers will never prevent the pilots recovering from an abnormal in-flight attitude. The flight control laws operate in alternate law without protections and stabilities. Load factor protection is maintained. During recovery, pitch reverts to alternate without auto trim or stabilities. Yaw becomes direct. Roll also becomes direct. Only load factor protection is maintained. After recovery, the airplane remains in pitch alternate law, yaw alternate, limited yaw damping, and roll direct. However, there is no reversion to direct law when the gear is extended, because the abnormal attitude law retains the flare mode.